chapter 12. Which is on differentiation. Right, okay, there are many rules that you have to follow, okay, how they come about, okay, we are not going to dwell into the how and why it is that way. If you want to learn it, you can pursue it higher at university, okay, but essentially it stems from this idea of limits, okay. I think your textbook has a little bit of discussion on limits itself, but we're not going to talk about that, okay. So with the many rules, okay, that also require a lot of practice, okay, to familiarize yourself with it. Okay, don't bother to actually go and memorize the exact rule itself, okay, but really it's about knowing how to apply all the rules, okay. So the first rule that we need to know is this thing called the power rule. Okay, the name itself also isn't that quite important, okay, you just need to know the idea. Okay, so what the power rule says is that if, okay, we have a function that let's say is y equals to x to the power of n, okay, then what we get in this differentiation, okay, will be n times x to the power n minus 1. Okay, let me break this down for you. Okay, this itself means the first derivative okay, since I'm using the word first derivative, that means there will be a second derivative also. Second derivative, okay, we will talk about it later on as we go along this year, okay, in terms of differentiation. Okay, so first derivative itself, we usually express it using this symbol. Okay, so this is a symbol. Okay, it is an operation just like your plus, minus, times and divide. It is not algebra. Okay, so you cannot cancel away the d and simplify it into a fraction of y over x. Okay, what it's telling you is that we are differentiating y. Okay, so we're differentiating y. Okay, with respect to, so in the denominator, we're looking at with respect to x. Okay, so x being the variable being discussed. Okay, that is what we're trying to differentiate. In our power rule, as the word suggests power, we're looking at the power itself of x. Okay, what we need to do is to bring it down, okay, into the same level as x, and then your power must minus 1. Okay, so that is what the power rule says. Okay, why do we learn differentiation? Okay, so before that I haven't quite mentioned why do we learn differentiation. Okay, differentiation, one of its common application is that, okay, it will help us to find out what is the gradient of a function. So let's say I have the curve, I want to know what is the gradient value at a certain point. Okay, if I know how to do differentiation, I can know the gradient. Okay, you will find that knowing differentiation and all this, okay, is very helpful, because in Emaths itself, okay, very often we need to find the gradient of a certain line. Okay, and how do we do that? We have to always draw our tangent, then find the gradient using our formula. Okay, so how do the teachers actually know that your gradient is it accurate or not? We rely actually on differentiation to find out the accuracy. Okay, so later on as we learn more, I will actually show you the helpful tips, okay, when it comes to joining it back to Emaths itself. Okay, so let me just show you how to apply this. Okay, looking at one example, try one. We are given that y equals to x to the power of 20. So how the rule applies is that dy over dx, okay, will be equals to power bring down, okay, power minus 1. So that is 20x to the power of 19. Okay, so that's your power rule. Bring down minus 1. Okay. Now, what if our function is 1 over x to the power of 40? Okay. First of all, I need to compare what's given with the conditions of our power rule. Our power rule says that it must be y equals to x, okay, not in a fraction, and then to the power of n. So the problem here is that x is found inside a fraction, okay, in the denominator in fact. Okay, so we need to re-express this into our negative index. Okay, so we have x power negative 40, so that's y. Therefore, our dy over dx will be negative 40x to the power of negative 40 minus 1. That is the part where we need to be careful. It is not negative 39, but it is actually negative 41. Okay? We could actually re-express this into positive index form if I want to write it like that. That's also fine. It depends on the question, what kind of format they want, but you need to know that they are equal, they are equivalent. Okay? Okay? Any questions up to here? So far simple, bring down power minus 1. Okay? Okay? Then there is this constant multiple rule that's found in your textbook, as well as this constant rule. I will not dive into the exact words of it, okay, because there is no point. The power rule really does cover as long as you get the idea. Okay, but I will do the example. So looks slightly different from what we saw in try 1. In try 1, notice that we don't have a number in front of x. There is no coefficient at all. Whereas in try 2, we are given that y equals to 8x to the power of negative 5. Okay, so what happens to this 8 over here? Okay, nothing will actually exactly happen to the 8. What we need to do is apply the same idea to find our dy over dx. So 8 remains there, power comes down, power minus 1, okay, because it is the x part that matters, okay, the x has the power, 8 itself doesn't matter, okay, 8 times negative 5 gives us negative 40, and then power becomes negative 6, okay. So in your textbook, this is what we call the constant multiple rule, okay. Because there is a constant in front of x. Okay. Part B. Okay, this is a little more complicated. We have y equals to 2 over 3 x cubed to the x cubed and then square root over the x cubed. Okay, and we want to find dy over dx. Okay, we always need to express our x, okay, such that it is actually on the numerator, okay, not found in the denominator of the fraction. Okay, and then have a very clear power to it. Back in our E-maths, when we learn indices, we already learned how to re-express square root. Okay, so for square root itself, what is the power that represents square root? Half, okay, so half. Okay, and then using our indices laws, we know that 3 times half gives us 3 over 2. If you don't know that, you can press calculator. Okay. So we now have the scenario, okay, set already for us to apply our power rule to 2 over 3 times x to the power 3 over 2. Bring down the power minus 1. Okay. Coincidentally, 2/3 times 3 over 2 becomes 1. So we have x to the power of half. Okay. Again, depending on the question, you can leave your answer like that, or you can rewrite it into its square root form. They are equivalent. Okay. Either one is fine. Questions so far? Okay, so over everything I'll be doing is just power bring down, power minus 1. That's all. Okay? Let's continue to extend, okay, to something that looks slightly more complicated. Okay, so now it's in decimal. Okay, we have y equals to 1.001x. We want to find dy over dx. Okay, so decimal and fractions don't really differ that much. Okay, so Xingxuan, can you tell me what would the answer be? Sorry? 1.001. Okay, just that, is it? Alright, so let's see. Okay, 1.001 because, okay, this is x to the power of 1. Okay, so our 1 bring down x power minus 1. Okay, so 1 minus 1, that gives us 0. Okay, and anything to the power of 0 is actually a value of 1. That's why it is 1.001. Okay? In the exam, you do not need to actually write down very clear steps like this. I'm just emphasizing to you about how our power rule applies to this question over here. Okay? So, you can actually know that as long as it's power 1, it's just left the constant. That's all. Our y is a constant number, okay? Y is just 99 square root 3. There is no number, there's no x to it at all, okay? So what happens is that you need to know that this is the same form as writing 99 square root 3 times x to the power of 0, okay? Because I can times 1, okay? If I times 1, then the value remains there, but of course I cannot times 0. If 99 square root 3 times 0, then it's 0 already, okay? So they are not equivalent. So this and this are equivalent. So apply our power rule. Power comes down. Okay, power minus 1. Alright. But then we know that we are multiplying by a 0. As long as we are multiplying by a 0 at any point in time, okay, of this particular term, it will actually become a value of 0. So therefore, this concludes for us that when we are given a constant number like this, okay, the differentiation, the first derivative will actually be equals to 0. Sorry, I forgot something. Forgot about dy over dx. Okay? So differentiate constant, confirm is 0, no matter what number. Okay? And then if you differentiate something that is x to the power of 1, it will just be the constant itself. Okay? try 4. We are given, okay, slightly looking something different, okay, no longer y's. Okay, the question says differentiate each function with respect to x. They define the function fx as this expression over here. Okay, so where is the y? Because if you notice, okay, when we do our differentiation, dy over dx follows, okay, because there's a y over here. So then now, how is my notation going to look like if I want to use something to represent the first derivative? Okay, does it mean that am I going to write is? Okay, answer is no. This is not what we are writing. Okay, so you need to be familiar with how all the differentiation notation looks like. Other than looking at it like that, if it is defined as a function, okay, fx, how we can represent the first derivative is that we write f prime x. Okay, prime in the sense that there's this complement sign, okay, similar to what we did in our set. Okay, so this represents the first derivative. Okay, just a different form of notation. Okay, but I cannot mix and match, Alright, this is when it is defined as y, but when it is fx, we write it as f prime x. Okay. Then, how to go about differentiating this? Okay, first of all, we see that we have this 2 over x cubed, so let's re-express that. Okay, so I will get 2x to the power of 5 minus 2x to the power of negative 3 plus pi. Okay, so let's start with 2x to the power of 5. Okay, what is the first derivative of 2x to the power of 5? Hui Jia, what would 2x to the power of 5 be? 2 times 5, x to the power of 4, great. Okay, then let's go to the next one, minus 2x to the power of negative 3. Okay, what will you get? Singing. So everybody's singing now. Okay, yes. What will you get for minus 2x to the power of negative 3? Let me put the minus there first. Negative 2 times. I can't hear you. I can't read your lips also. Negative 3 times 2, is it? Okay, so negative 2 times negative 3 lah. Because power breakdown. Okay, then x to the power of negative 4. Is that what you said? Okay, so negative 4. So negative 3 minus 1, we get negative 4. Okay? Then what about the pi? Okay, what do we get for the pi? Chloe P. Chloe P is she, her, right? No, oh, sorry. I only recognize the name. I cannot recognize the surname yet. Yes, Chloe. It is 0. Okay, yes. So pi is a constant number, so we get 0. You don't need to intentionally write this, okay, as working. I'm just intentionally writing it because I want all of us to know what we're doing. Okay, so we get 10x to the power of 4 plus 6. X to the power of negative 4, you can write it like that. Okay, and then this is the final answer that we'll get. Okay. Any questions? Okay, next part B. We have x squared minus 3x plus 7 over 2x. Okay, very different from what we have been looking at so far. Okay, any ideas at this juncture about what we'll do? Maybe. Yes. Change the denominator. Put it to the top. So can you tell me what will you write? X squared then minus 3x. Sorry, I didn't catch you. Bracket. X square bracket. Oh, sorry, I cannot hear you at all.
X square minus 3x plus 7.
Oh, okay. X square minus 3x plus 7. Negative 2x.
Like power negative.
2x.
Negative power. Like power is negative.
Power is negative. Oh, like that. What do you think? Chloe, what do you think? Never mind, maybe it's a good try. Okay. How? Is it correct? No, right? Okay. So what should happen? Okay, this is in the denominator. Alright. What this means is that, okay, if you want to put up into the numerator, right? Okay, we can put 2x to power negative 1 now, like that. Okay, they are equivalent. Right? Because in the denominator, entire thing shift up. Okay, entire thing must be to the power of negative 1. Okay, but is this helpful? At this juncture, we only know our power rule. We don't know anything more. Okay, and also there's a simpler way of doing it. So even if you know more stuff already, okay, that might not be that efficient in doing for this question. Okay, so while these two are actually equal to each other, it is not helpful for us to move forward. Alright? How? Next. Okay, what I need you to notice, okay, is to extend this idea, okay, back to our basics first. Okay, if let's say I have 2 minus 6, okay, maybe not 2 minus 6, okay, maybe 8 minus 6 over 2, right? Without going to calculate 8 minus 6 for me, which is equals to 2, okay, how do I separate out this fraction? How do I write this into two separate fractions? 8 over 2, then minus 6 over 2, right? Agree? Yeah, equal, huh? Okay, then I can say that 8 over 2 is 4, 6 over 2 is 3, we know that's 1. Okay? We know we are correct because we know also 8 minus 6 is 4. Okay, so 8 minus 6 is 2, divided by 2, and then we get 1. So they are equal. Right? Okay, so this is how we go about simplifying fractions. It's a skill that we already knew. So for this one, okay, what I need all of us to agree on is that we can rewrite it as x squared over 2x minus 3x over 2x plus 7 over 2x. Okay? Why do we want to do that? Because at this juncture, I only know how to differentiate term by term, okay, by applying our power rule. So I want to separate this out into 3 separate terms, okay, to apply my power rule. Alright? So x squared over 2x, okay, x squared means x times x, 2x means 2 times x. They mean different things. I can simplify it to write it as x over 2, okay, by cancelling out 1x. And then for this 3x over 2x, I can cancel out both x's, and then I'll get 3 over 2. And then 7 over 2x. This one itself, nothing for us to simplify anymore. Okay, but we know that my x cannot be in the denominator. For us to actually do our power rule, we must have it in the numerator. So I'm going to keep the number 7 over 2 itself. X, I'll put it up in the numerator, or maybe just at the side. It means the same thing, so I get x power negative 1. Okay? Is anyone lost at this re-expression phase? We haven't done any differentiation, we're just rewriting, okay, the question. Alright? So now, then we can move on to our differentiation. Okay, since all the x is now along the numerator already, x over 2 means half x. Okay, so same meaning. Maybe this out, that's right. Okay, so half x, when I differentiate differentiate half x, what will I get? Save. Half. Oh, okay, half. So we get half for half x, and then minus 3 over 2, what is the differentiation going to be, Vanessa? Differentiate minus 3 over 2, 0. Great. Okay, so you can write 0, minus 0. Okay, don't write, also can. Alright. Next one, 7 over 2x to the power of negative 1. Okay, what is that derivative going to be, Ashley? 7 over 2x to the power negative 1. Negative 1 times 7 over 2. Okay. Then x to the power negative 2. Wait. Alright, so we simplify. You may write it like that, or you want to re-express it like this, also okay. Any questions? Okay. Before we dive into application of anything, okay, I want us to actually practice many questions first. Okay, so I want you to do question 2C, 2F, 3A, 3B, 3C, 3D, 3E, 3F, 4C, 4E, 5A. Okay? I want you to do it now. Right? If you don't get past this, okay, the entire volume B is gonna be difficult. Alright? Yes, go. Okay? I'll give you 20 minutes to work on this. If you still don't get anything, okay, don't understand, raise your hand, I'll come over to help you. Okay? just like your plus minus times divide. Okay, not an algebra. Okay, so you can write it like that also can. Okay. Mistakes that some of your classmates actually have, okay, so that you can actually prevent yourself from doing the same mistake. Okay, I think at the start, okay, when we jump into all these questions, many of us will start with 2C. Okay, I hope that you have clarified about what 2C entails. Okay, what you really need to recognize, okay, moving forward is that you need to know what is coefficient and what is variable. Okay, so in this case, coefficient is your pi square over 3 and negative 2 over 5. So you need to separate out those ideas, which I think Chloe over here has done it very well. Separate out the coefficient from x, okay, so that you can see things very clearly. Okay, how is the coefficient going to multiply with 2? Okay, hope that the people at the back can see it because the writing will be cramped and the marker point is very thick. Okay, so your answer should actually be 2 pi square over 3 times x minus 8 over 5x cubed. Okay, so this answer is good. Then it is over here, okay, one challenge in this question is that A and B are actually constant numbers. Okay, so you need to recognize they are not variables. They are just a number that the exam does, that the question doesn't want to give you what's the number. Okay, but we work with it as though it's a number itself. Okay, so A over 2 is a constant, differentiate to become 0. B over 2, okay, and then the power bring down 3. Alright, so this answer is correct as well. Okay, at this juncture also, I want to point out that the presentation here is good such that the y's are all in this equivalent form. dy over dx is after the differentiation has been done. Okay, because going to Klein's work here, okay, over here, negative 5 over 4 x or negative 1 over 5 is actually the question itself. That is actually hx, not yet differentiating. Okay, only here then she starts to differentiate. So therefore, it's only at this part then put h prime x. Otherwise, the idea of equal, okay, doesn't hold because this and this are definitely not equal at all. Okay, so do take note of presentation issues, okay, to convey the correct meaning. Alright. Then I noticed that for Wayne and Davian, they actually skip a little bit of steps, but the answers are correct. Okay, no harm in skipping those steps. Okay, so for Davian, he can see that x is actually x power negative 1 already. Then he don't bring down and all that. It eventually gives us x squared. Okay, so if you're quick enough like that, that's fine. Okay, not an issue. Then Regine's answer is also okay. So likewise, all your denominator x need to bring up. Okay. For Ray's answer, I think copy wrongly the question, so actually should be minus, not a plus. Therefore, the answer follow through is not correct. But the idea of differentiating, you got it already. Okay. Then Teacher's one is okay, Megan's one is okay as well. Okay. Then last one, okay, Matthew's one. Okay. A little bit of carelessness. Down here is a minus 1, so down here should be a minus. Okay. Then minus as well. Okay, then over here I am very lost and confused already. That's why I write it like that. Okay, so trying to differentiate this x to power negative half over here. The negative half bring it in front of x. Okay, because this is telling me that it is x times negative half. Then the negative half to the power of negative half minus 1. Okay, but the power should be with the x bar. Okay, then this constant should be in front. Right, so constants always bring down in front. Okay, so that's why the answer is a little bit messy over here. Alright, okay, then this one I also don't understand what it's trying to write. Maybe that's a bit too cramped. Okay, so hope this clarifies. Okay, if still not sure about anything, we'll come back on Monday to clarify on things. Okay, those that are not done yet, please go back and